In this video, we are going to go over naming branched alkanes. So naming substituted or branched alkanes, first you need to find the parent name. The parent chain is the longest carbon chain in the molecule. The substituent or the branch is the group bonded to the parent chain. There may be more than one substituent or branch in a molecule. An alkyl group is a substituent derived by removal of a hydrogen from an alkane, and you drop ane from the name of a parent alkane of the substituent and add the suffix -yle. So you can see here that we have CH3. CH4 is a one carbon alkane, straight chain alkane, which is called methane, right? Meth is one carbon. If we remove a hydrogen, we get CH3 and we get methyl. The -yle means that it's a substituent, which means it's bonded to a parent chain. Same with ethyl. This means that there's a two-carbon chain bonded to a parent chain, and it looks like this right here. On this carbon chain, there's a 9-carbon chain. In this example, we have a methyl bonded at carbon 3, and at carbon 6, we have an ethyl. It's a 2-carbon substituent. So identifying the parent chain, to find the parent chain, you look for the longest carbon chain. So we see if we're numbering on the left one, if we start from the bottom and you put your pen down and you trace the line without picking up your pen, that is a chain. So we start at 1, we go to 2, 3, 4, and that's 4 carbons. If we go on the second one, we go left to right, we go 1, 2, 3, 4, 5. This is a 5-carbon chain. The 5-carbon is longer than the 4-carbon, therefore 5 carbons is the correct parent chain, not the 4-carbon. Another thing you need to consider for identifying the parent chain, if two chains are equal length, so you count a parent chain or a chain and you get the same number of carbons both ways, you select the one with more substituents to be the parent chain. And then the parent chain is determined with whose substituents have the lowest assigned number. So you also want to number your parent chain so that your substituents have the lowest assigned numbers as well. So you can see here, we have 2 substituents on our parent chain. We found our parent chain. If we did 1, 2, 3, and we went left instead, this would be 4, 5. This chain is less than 6, therefore that would not be the correct parent chain. So that's why we went 1 through 6. We see we have a 1-carbon substituent on carbon 2 and 1 2-carbon substituent on carbon 3. 2 carbons is eth, so this is ethyl. 1 carbon is methyl. We also see that we number carbon 1 at the top and go down to the bottom. If we started at the bottom as number 1 and we number successively, so 1, 2, 3, 4, 5, 6, we have our substituents on carbon 4 and 5. We want our substituents on having the lowest assigned number. So if we numbered from right to left or bottom to top, our substituents would be on carbon 4 and 5. When we go from top to bottom, they're on 2 and 3. 2 and 3 have lower assigned numbers than 4 and 5, so top to bottom is the correct way for numbering. Again, another example is over here. We have a substituent on carbon 3. If we numbered from right to left, it'd be 1, 2, 3, 4, 5, 6. And if we numbered right to left, the carbon that our substituent would be on would be carbon 4. That is a higher number than carbon 3, so that's why it is numbered from left to right. So this is an example. Pause the video, and when you're ready, we'll come back and work on it together. So the first thing we do is identify the parent chain. So what we're going to do is if I go from left to right, I did 1, 2, so 1, 2, 3, 4. That's 4 carbons. If I go up for the branch and go 1, 2, 3, that's not as many as 4, so that's incorrect. So our carbon chain is 4 carbons, which is but, is our prefix. It's an alkane, which means the ending is ane. We have a substituent on carbon 2. So carbon 2 has a substituent. It has a 1 carbon substituent. 1 carbon is meth. It's a substituent, so eel means substituent. And then we're going to put it all together. So what we do is we put our substituent first. We have to put a 2 to indicate where it is. So our locator number. So 2 dash, what kind of substituent it is. So 2-methyl. And then the parent chain name, butane. So there's a methyl group on carbon 2, and the parent chain is butane. So there's 4 carbons, and it's all single carbon single bonds. Draw the structure of 3-pentyl octane. So the first thing I'm going to do is I'm going to draw my zigzag conformation of octane. Oct is 8. Ane means that it's an alkane, so only carbon single bonds. So this is 1, 2, 3, 4, 5, 6, 7, 8. On carbon 3, there's a pentyl. So eel means that it's a substituent. Pent means 5. So on carbon 3, there's 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. 5 carbons coming off of carbon 3. So this would be the structure for 3-pentyl octane. For compounds with 2 or more side chains, you use prefixes such as di, tri, tetra to indicate there are multiple side chains of the same type. So di is 2, tri is 3, tetra is 4. You use commas to separate numbers and hyphens to separate numbers or letters, and you name the side chains in alphabetical order. So you can see here that we have a 6-carbon chain, which is a hexane. And we have 2 methyl groups, 1 on carbon 2 and 1 on carbon 3. So 2 of the same group is equal to di. We're going to put a 2, comma 3. So the 2 methyl groups are on carbon 2 and 3. We put dimethyl, so 2 methyls, and then the parent chain name is hexane. So practice, pause the video. When you're ready, come back. Okay, draw the skeletal structure for 2,2,3-trimethylpentane. I'm going to first do my zigzag conformation. Pentane, pent is 5. So this is 1, 2, 3, 4, 5. Trimethyl, methyl means it's 1 meth is 1 carbon substituent, and there's 3 methyls. So on carbon 2, I have 1 methyl, 2 methyls, so my 2's are gone. And on carbon 3, I have 1 more methyl. Write the IUPAC name for the following branched alkane. So I'm going to number my longest chain and do 1, 2, 3, 4, 5, 6, 7, 8. I'm going to double check that that's my longest one. So if I went 1, 2, 3, 4, and then up, this would be 5, 6, 7. 7 is shorter than 8, so this is my longest one. I'm going to double check that this is the right order. So if I went from right to left, it'd be 1, 2, 3, 4, 5, 6, 7, 8. If I went that way, my substituents would be on 5 and 6 instead of 3 and 4. Those are smaller or bigger numbers, and we don't want that, so that is not the correct numbering. I know that 8, the prefix for 8 is oct. This is all carbon-carbon single bonds, so that's an alkane, so it's ane. I have a substituent on carbon 4. It's 3 carbons, so it's prop, eel. So this is 3 carbons. On carbon 3, I have 2 carbons, which is F. It's 2 carbons. And when we do this, we're going to write it in alphabetical order. So what I'm going to do is I'm going to write 2 ethyl. And we have the 2 hyphen ethyl hyphen, or sorry, that's 3. 3 ethyl, 4 propyl octane. So there's an ethyl group on carbon 3, a propyl group on carbon 4 with a chain of 8. So in summary, for naming branched hydrocarbons, you have to first identify the parent chain or the ring, or the longest continuous chain of carbons, and then identify the type and location of each substituent on the parent chain. When there are 2 parent chains of equal length, the chain with more substituents is selected as the parent chain. Alkyl substituents are assigned a name based on the number of carbon atoms in the substituent, and the ending is changed from -ane to -eel. And then you number all the carbons in the parent chain starting from the end closest to a substituent, and a locator number is assigned to each substituent based on where the parent chain is located.